Well, hello, everyone. Welcome on in. Thank you so much for giving me yesterday. Had to pay tribute to a great person. We keep losing more and more of our young people, so we just really have to remember, be in touch with people around you. So hopefully everyone's doing all right. Thank you again for yesterday. I greatly appreciate it. Actually, what I've been working on all morning, which kind of got me in a tizzy, is I am working on downloading all of my replays. So I'm trying to put all that onto my YouTube, and good God, I didn't know how many replays I had. So, whoo, it's been a long night. Hello, film artist. And then originally I was going to do dividing polynomials. And then I said, you know what? I've been getting a lot of responses with people saying that, Audrey, this is really helping me out. One person said, I got a 91 on my test because of the review that you did. Another person said, I got 92. I am just like really happy about that. Like, it's really doing my heart solid. So I said, okay, well, let's not do dividing polynomials. Let's do something that's actually going to be on, I think a lot of people call it the TEAS test, TEAS. And I think it's going to be something that everyone kind of knows about, but every kid does, the Pythagorean Theorem. So we're going to be doing a little bit more geometry. And just like how it plays out and where is it coming from. So, of course, I just quickly threw some stuff together. This is what we're doing. We're taping stuff in. That's what it is. We're keeping it real. Just taping everything in. So, if anything, Pythagorean Theorem is your jam. If you know anyone that's taking the TEAS test, that's doing geometry, that's doing Algebra 1, even people that are doing trig, they probably already done this, but hey, there's something called a final. Before you know it, it's time for us to take finals. It's crazy. Just have them come on in, share the live. And I am going to be here for just a little bit. I have to definitely get off at 2:15. So before I do all of this, I'm going to see if I can zoom in. I'm pushing buttons. I don't even know what I'm pushing. It's going to be a little messy today. But I definitely want you to get the formula down. So Pythagorean Theorem, a lot of us know it. A squared plus B squared equals C squared. All right. This only works when you have a right triangle. So go ahead, type, make sure you have for your formula, the C squared. The C is always your hypotenuse. That's how it's called. Hypotenuse. Okay. Okay, so that is always going to be your longest side. That is your hypotenuse. Now, the longest side is always opposite. So you're like, okay, well, Audrey, how can I tell? It's always opposite the 90-degree angle. And that 90-degree angle is always like that box, okay? Sometimes we just see like a little box in the corner. That is going to be your 90-degree angle, okay? So the other two sides, they're called legs. Now, the legs are interchangeable. So if you're always stressing yourself out, trying to figure out which one's going to be my A and which one's going to be my B, it does not matter. Okay, they're interchangeable. So if you got one side that you figure is going to be your A and the next triangle, it's going to be your B, hey, go at it, okay? Because that's basically what is happening. They're interchangeable. So this is only used for right triangles, okay? So right triangles meaning one of your angles is a 90-degree angle and the other two could be a 45-45. like an isosceles right triangle. Or it could be a 30, 60, 90, which is like another form of a special triangle. All right. So with that being said, when we're going to go into Pythagorean theorem, we need to say, how are we going to know that something is a right triangle? So how do you test this out? So right now, let me give you some of the parts. So if you already got that screenshot, let me give you some of the parts of what is a right triangle. So let me bring this down and let me unzoom just a hair. All right. So here we have a right triangle. Okay. So eventually, get my zoom all kinds of crazy. So, oops, hello. All right. So with the right triangle, see, we have our 90-degree angle. Okay, so this angle is 90 degrees. It's also called a right angle. Okay, so the hypotenuse is the longest side of the triangle, okay, and its opposite the right angle. So here's my right angle. Anytime the side that is directly opposite, directly across from your 90-degree angle, this is going to be your hypotenuse. And you're probably going to see me because eventually we're going to go into a little bit of trig, like sine, cosine, and tangent. Yep, we're going to be doing some of that too. Okay, probably not today, but we're definitely going to be touching on that. So when you have the side that's directly opposite your 90-degree angle, it doesn't matter if you're, let's see if I get my trusty pencil. It doesn't matter if I go like this. Oops. Okay. If I choose to make my right angle, my right triangle look like this. Okay, no matter what, the side that's directly opposite of that 90-degree angle, that's always going to be my hypotenuse. Okay, all right, it's always going to be my hypotenuse. So now these sides are called legs. Okay, and the legs, as I said, are interchangeable. Now, in order for us, let's just say, for instance, I'm just going to have you kind of take a look at this. All right. So if I gave you 3 sides, let's say a 3, a 4, and a 5. And I want you to tell me, is this a right triangle? And you're going to be like, girl, it's just 3, 4, 5. It's just 3 numbers. Like, how am I supposed to know? Should I draw it out? You know, should I take your dots and go, okay, here's 1, 2, 3, and then here's 1, 2, 3, 4. Should I do this like a triangle like this? And then I just draw this other side and say, okay, if this is going to be my 5, because that's the longest side, so that means my 90-degree angle is going to be right across from it. And then I can say, all right, this is my 3, and this is my 4. Now, you can do that. I'm going to tell you, you don't have to do this each and every time, okay? You can tell that something is a right triangle by just using the measurements. Let me show you. So I know if I take what's called the square. I almost said the cube. Ooh, I've been working on cubes lately. So if I take the square of the 3, I'll take the square if I just square them. Okay? And the reason why I'm squaring them is, remember the formula. So the formula, a squared plus b squared equals c squared. Okay? So if I take each of those numbers and I square them. So square meaning 3 times 3. Okay? Square meaning 4 times 4. 5 times 5. So if I take the square of 3, so 3 squared, that gives me 9. 4 squared, that gives me 16. And 5 squared, because it's 5 times 5, that gives me 25. Now here's the thing. This is how you can tell if it is going to be a right triangle. Take the sum of the 2 smallest squares and see if it equals the square of your largest. So, in other words, 9 plus 16, does that give me 25? Okay, yes or no? Go ahead, put it in the chat. 9 plus 16, does that give me 25? All right, film artist says yes. Okay, Karen says yes, good. And like we all said, things gotta happen in 3s. So who's the next brave artist? Oh, thank you for the roses, Stephanie. I'm so sorry. What do you think? 9 plus 16, we got 2 people saying yes. Always gotta be solidified in 3s. Who is the next brave person? There we go. Thank you, Nano. All right, so 9 plus 16 gives me 25. 25 does equal 25. So that means this 3, 4, 5 does give me a right triangle. Okay, so yes, it is a right triangle. All right. But sometimes on the test, they don't give you something as easy as that, right? They always want to give you something a little more complicated. So, like, let's say they'll give us like 26. So I'm going to get my example right here. So we have 26, 24, and 10. Okay, so you need, well, thank you, Potato. Okay, do you always square it? Yes, yes. So the rule is you always take the square, I should say the sum of the squares of the 2 smallest numbers. Okay, so you're taking the sum of the 2 smallest numbers and you want it to equal the square slide over a little bit, the square of the largest number. Okay. So if you take the sum of the square of the 2 smallest numbers, it needs to equal the sum of the largest number. Now, for the example that I just showed you, they're starting off with 26, 24, and 10. So here's my thing. Can I rearrange this so I can make sure I have the sum of the two smallest numbers? Or do I have to keep it like that in that order? Okay, yes, you can rotate it. Okay, you can rotate it, you can move it. All right, so if you want to, you can rearrange it. And then you can say, all right, I got 10. Then the next one is 24. Then the next one is 26. So now, before it looked like, oh, it has to equal 100 square. No, it's going to be your two smallest, the square of your two smallest, and have it equal to your larger, the square of your largest. Yes, films. So that means we have 10 squared plus 24 squared. And we want to see if it equals my 26 squared. If it does, these are the measurements of a right triangle. If it doesn't, it's not the measurement of a right triangle. Okay? So what do you think? Okay, so Film Star says yes. Do we all agree? Oh, children of the sun. Lovely to see you again. Okay. Are we okay? All right. Okay. Oh, Sonia. So if we have 10 squared, that gives us 100 plus our 24 squared. So you're probably like, oh, what's 24 squared? Because that's not off the top of our head. So 24 times 24, perfect square, will give me 576. And then 26 squared, that gives me 676. And last time I checked, 100 plus 576 will give me my 676. And since they're equal, this is a yes. It's a right triangle. So good job, film artists. Okay. Questions on that so far? Okay. Simple enough. All right. So now let's take it up a slight notch. Let's see if we can do some solving. And I'm going to show it to you in different ways. All right. So if I come here, I'm going to just tape in this one problem because I was able to find some and I was like, oh, well, why recreate the wheel if it's already done? Just seems like a simple task. All right, so we have this here. And I'm going to raise this up. All right. So we have everything all nice and in. So we have a triangle right here. And again, it's a right triangle. And how do I know? Because it has this little box. That's right smack here. Now, 90-degree angle, that means the side that's opposite that 90-degree angle, that's going to be my hypotenuse. So that means the other two sides are going to be my legs. Okay, remember my legs are interchangeable. So if the lower two numbers are equal to the bigger one squared, they're right. Correct. But make sure that they're squared, Joe. Make sure that they're squared. Okay? Good. All right. So Pythagorean's theorem. So that's our a squared plus our b squared equals our c squared. So we know the hypotenuse and we know one of the legs, okay? Doesn't matter. I can just say, all right, this is A. I'm going to make that the A side. I'll make this the B side. And then we know the hypotenuse is always going to be your C. So if I am solving this, I need to plug this information into my equation. So it doesn't matter what the A and the B, they're interchangeable. I just picked, right? So for my A, I'm going to have a 6. So that's my 6 squared. For my B value is the unknown side, which is my X. And that's going to be squared. And my C, which is my hypotenuse, that's going to be 12. And that's squared. Raise her up so you guys can see it. It won't be all in the comments. All right. So now we're going to do some solving. So right now we're going to put off to the side. We just got the information that we needed from our figure. And now we're going to do some solving. 6 squared. Okay, what's 6 squared? Hello, Lisa. Okay, good. So 6 squared, we got our 36. Good. All right, x raised to the second power, that's going to be x squared. So I'm not going to insult your intelligence. You guys know that part. But what's 12 squared? Hello, pretty eyes. Okay, good, Lisa. Good, good. Oh, lovely dimples. How are you? All right, nice, excellent. We got 144. Now, we're going to solve this equation for x. We want to know what that unknown. Paula, good job. Lady Liberty, good. Now, what do we need to do so we can isolate our variable, that x squared? What do we need to do? And then Lisa, how did you get the 108? Okay, so Pretty Eye says minus 36. Okay. Well, it's not so much bring it down, but yes. So we can subtract. Make sure it's 144 though. Okay, there you go. Good. It's like, wait, catch, wait. All right. So if we subtract the 36, then now we're going to bring down that x squared. And then we got our 108. Okay, good. Okay, so we subtract the 36 on both sides. And then we got our 108. So we have x squared. All right. So it's not so much squaring both sides. What's the opposite or the inverse of squared? Okay, what's the opposite or the inverse of squared? And it's not a circle. I had a kid tell me that. Opposite is a square. I was ready to jump through the computer screen. Like, really. Okay, yes, there you go. So they will cancel out when we do the square root. So the opposite, just like how we say the inverse of positive is negative, The opposite of multiplying is dividing, okay? The same thing is going with between squares and square roots. They cancel each other out. So that's how you get your x is equal. So we got x is equal to the square root of 108. So now, some people will say, okay, well, now we got the square root of 108. We can probably just put that in our calculator and then figure out what the decimal version would be. Okay? This is where I'm going to have to say, you're going to need to check your answers. There is a way that we can simplify the radicals, but also check what they're saying. If they're saying round your answer to the nearest hundredth, that means we want the decimal. So that means you need to put the square root of 108 in your calculator to figure out the decimal and then round. If it says find the exact value, that means we need to simplify this 108. And I'm going to show you both, okay? So let me scooch this over a little bit. I'm going to use this space that I have right here. So if I need to simplify the square root of 108, this is when factoring is going to come into play, especially knowing your multiplication table. We want to factor this 108 to a perfect prime combination. So we want a perfect and we want a prime. Okay? So now, this is when my little handy dandy, I don't know why I put it on that page instead of this page. Okay, so this is when my little handy dandy factor sheet's gonna come in. So we need to figure out, we need to figure out, and we need to unzoom. There we go. 108. So we need factors of 108. So we have 108. So we got 1 and 108. We got 2 and 54. We got 3 and 36, 4 and 27, 6 and 18, and 9 and 12. So these are all factors of 108. Now I saw some of you guys says 54. True. But 54 can be broken down even further. Prime 2 is definitely a prime number, which is good. But 54 is not a perfect, okay? We can do 4 and 27, but 27 can still be broken down with 9 and 3. 9 is also a perfect square root, okay? So if you notice what's highlighted in red, this will be your perfect prime combination because the square root of 36 will give us what? I think Film Artist gave it to me. Yes, Film Artist gave it to me. So 6 and 3. The square root of 36 is 6. Good. Thank you. All right. Square root of 3 is prime. So it can't be broken down any further. So you could do 2 and 54, but you have to break down the 54. You could use 4 and 27, but you will still have to break down the 27. So for me, I kind of like to get right down to the nitty of the gritty. You know what I'm saying? So we get with the 3 and 36, that will take us straight to where we need to go. So let me unravel. I know, there's like so much that's going on here. So much. Okay. All right, so coming back to the 108. So I'm going to put my 36 here. I always like to put my perfect in the front. Okay, so then we have our 3 here. Because the square root of 36, that's going to give me 6. Square root of 3, it can't be broken down because it's prime. Since it can't break it down, you bring it down. Okay, so the breakdown or your x keeping it as an exact value, that's going to be one of your answers. 6, the square root of 3. Okay. Yeah, it's a perfect square. What is in the what, darling? True. Okay, I'm jumping in all kinds of weird. So like, Sean, did we answer your question? Okay. Cheekington. Funny. 2 root the square root of, do you see why it's not the 2 root the square root of 26? Okay. All right. So this will be the exact value simplified. Now, if they wanted the decimal, obviously you would go into your calculator, or sometimes they give you the calculator that's electronic, and they would say, all right, we got the square root of 108, and they will give us our decimal form. So if we need to round to the nearest hundredth, okay, remember hundreds with the TH is the second decimal place. That means we need to look at the third decimal place. That helps us with our rounding. So if I just look at the third decimal place and just basically ignore everything else, I'm looking here at the 2. If it's a 5 or above, we usually add 1 to the 9. If it's 4 or less, or 4 and below, we just leave it alone. So since it's a 2, it's less than 4, so we're just going to leave it alone. So that means my decimal version will be 10.39. Hey, how are you? Yes. So I'm going to write or. X is, and since it's rounded, I'm going to use my approximate symbol, which is like the little waves. So if you ever see the little waves, you're like, what is that about? You know, it's not an equal sign that just had a mad night of partying the night before. It's because we're approximating. All right. So if they want rounded, that'll be your decimal form. If they want exact, that'll be your simplified radical form. Let me slide that over so you can see. All right. Okay. Now, I want to say of most programs that I see online for students, like Khan Academy or OutSchool or any of those like IXLs, or even just when people are just starting out as math tutors, the very first thing or the one thing that they always use as an example, Pythagorean Theorem. Every time. It's like, okay, there is so many other math things, but it's easy to understand. It's very visual. And sometimes you don't have to go too crazy with calculations, right? Hey, Jasmine. Thank you for it. All right. So let's do another one. Let's try to make it a little more real. So let me unzoom so you guys can take your snapshot. Let me zoom in with the formulas, and then I'm going to zoom. Whoa. I'm getting kind of crazy with my zooms today. It's like, whoo. All right, screenshot. Okay. David, no, I don't do those. I definitely do not do differentials. I do not do calculus. All right. And then if you do need somebody to tutor you on calculus, I got a guy. Just message me and I will pass that information over. Okay. And I'm going to raise up just a hair or more than a hair. And then you can take a screenshot right there. Okay. All right. Okay, so I'm going to dig down a little bit deeper. Okay, if round to the hundreds, focus on the second number. No, if you're rounding to the hundreds, focus on the third number. Okay, the third number. So the third number is going to help you round to the second number. Okay, so before I go any further, I've decided, because I've been talking to a lot of other educators, and I'm not sure if you guys are with these people or not. One person that I definitely want to shout out is Impact Math 19. She's usually on right after me. She goes through step by step with a lot of the concepts for ACCUPLACER, basically similar to what I do. If you need someone for chemistry, right? I'm trying to I figured on Fridays I should shout people out. Why not? We're all into this. Another person is Professor, I think that is, yes, Professor TK, and this is for chemistry. Okay, she usually goes live around 10 o'clock Eastern Standard Time. Really awesome with details and figuring things out, right? I haven't found anybody for social studies. That is so true. I might have to see if I can bond up with some other people. I also mention, hey Tiffany, a blessed, a blessed RN. So if you're thinking about going into nursing school and just how to calculate dosage, which is huge, we don't want to kill anybody, right? She has actually have a way that she can use puzzle pieces, how to basically look at proportions and reduction, but she puts it in such a way that it's memorable and it don't have to worry so much about math, okay? Just how to reduce it, okay? Yes. Check the stone to see if you can link up with other teachers. Okay, I will definitely take a look at that. Praise Root Math 2. Yes, never saw that person, but I will look them up as well. All right. And the other one, my friend Learning with Net, she is really blossoming up there. If you want to learn how to do math using the abacus, now she's starting to get a lot of adults that are coming in, and she's actually reconfiguring a book that's going to be helpful for adults to learn how to use the abacus to teach their own kids how to do math using the abacus. So it's really physical thing. So definitely reach out, link up, look at their lives. They're awesome, so I will definitely take a look at Praise Root Math, as well as I'll just check out the STEM category. Thank you, Just Clean and Lisa. And then also I'll see if I can find someone for social studies. I don't know, but I'll take a look. What's going to happen? Something will happen that I'll find somebody. Never know. It might be a love connection. Might have some more math babies. No, I'm just kidding. Definitely just kidding. All right. So, taking a look, I'm going to try to make it as real as math as possible. So, I'm going to tape this bad boy down. You should really see my desk right now. Oh, you just get away from it for one day. Isn't it weird? 1 minute, everything was all nice and clean. And then you just have a day of you know what? I'm just really sad. And I just want to be sad. And then all of a sudden you're like, what the hell happened to my office? And there's no one else in this house. I can't blame it on kids. I mean, what? The cat's trying to learn? What's going on? Ugh. But I'll be getting my life together. All right. So here is another. See if I can zoom in so you can see it, and then I'll zoom out for the calculations. Okay, so sometimes you'll see things like this. Midterm. What? How did you fail your midterm? Okay, yeah, I'll definitely do that. So what do you mean you failed your midterm today? What happened? What's going on? This is super helpful. Not a problem. Okay. All right, so you'll tell me. But if anything, we just have to learn from it. Since it's your midterm, remember, you still got a final. And all those things are going to come back. So if you need assistance, I am putting together this study group. Right now, I love when people say I want to do 9 a.m. Another person say I want to do 9 p.m. And another person say 12 o'clock works for me. So that's the hardest part about doing it. But I really, in my heart and soul, want to do it. Confused with all the material. Yes. Okay. So now we have to figure out. We can't just sit there and try to consume everything at once. We got to do it in bite-sized chunks. Okay. So 1, make yourself be sad for today. Get it all out of your system. But tomorrow, we're going to reconstruct how we're going to study. So if that means you have to make flashcards, if that means you're going to have to dedicate some more time for studying, more time for practicing, that's what we're going to have to do. All right? Hello, Hunter. Yep, we're not on that part yet, Hunter. We're just still working on Pythagorean Theorem. All right, so now we have a triangle here. Duh. Right? They're giving me a length of the whole side, which is 10. They're giving me one side, which is 13. And they're giving me an unknown side, which is x, right? So if you take a look at it, don't look at it as a whole triangle. Let's take a look at it by taking this chunk away. And now we're looking at it from this triangle right here. So as you can tell, they gave us the symbol for 90 degrees. But we need to take a little bit of the information that they did give us. They told us that the whole length of this side is 10. And they're giving us these little indentations. This is saying from here to the center is exact same length from here to the center. So if this whole thing is 10, okay, what we got? Film artist, yes. Just clean chemistry, yes. All right. So we can't say, who said it was an equilateral triangle? Okay, just clean, be careful. It can't be equilateral, because if it's equilateral, all 3 sides will be the exact same length. This one is 10 centimeters. This one's 13. Okay? All right. So now that means we're taking half of this base. So from here to here is going to be 5 centimeters. All right. So now we also know that directly across from that 90-degree angle, thank you so much, is that hypotenuse. Remember, no matter where that 90-degree angle is, the side that's directly opposite is always your hypotenuse. So now let's get with it. A squared plus b squared equals c squared. Your A and your B is your legs. They're interchangeable, okay? After I typed it, okay. I was like, hello, queen. Yes. Also, if you know your triples, you would know that it's a 5, 12, 13 triangle. Yes, true. Now, here's my thing. You're asking people to remember something. Sometimes, especially when you're just doing these tests, these ASVAB, the ACCUPLACER, all that stuff, you really don't have time. So, the leg thing again? Yes. So the two legs, the two sides, that's not the hypotenuse, they're interchangeable. So it doesn't matter which one's your A and which one's your B. Okay? So I could say, all right, my 5 centimeter one is my A side. My unknown side could be my B side. And then the 13 will be my hypotenuse. Okay? If you wrote x squared plus 5 squared equals 13 squared, that's fine as well. That's why I'm saying that they're interchangeable. It doesn't matter which one goes where. But the hypotenuse is your longest side, the one that's opposite the 90. So 5 squared gives me 25, not 10. That was another thing I was ready to jump through. I think it was just I was not in the right mood yesterday. But I was seriously ready to jump through a TV screen. It's like, all right. So 5 squared means 5 times 5. The number of times you're multiplying the base to itself. So now 13 squared, that's 13 times 13. So it's not 26. Okay. Commutative property of addition. Sure. So, you have your 25 plus your x squared equals 169. Now, with your 169, what are we going to do so we can get x squared by itself? Okay, so J is saying minus the 25, minus the 25. We're not square rooting yet. Okay, we got to isolate. Good. Okay, you correct yourself. Good job. All right, so we have to subtract the 25 on both sides. So 25 minus 25 cancels out there. Then we have our x squared. And then our x squared is 169 minus 25 gives us what? Hi, Michael. Well, for the x squared, will give us the 144. Yes. Now, I think I saw Lisa saying it's 12 and a couple other people says 12. How do I get rid of the square? Good job, Iris. Good. Now we square root. She's like, I got my fame right here. This is it. Okay? So the opposite or the inverse of a square is a square root. So that square and that square roots, they cancel out, leaving me with the x equals, all right, square root of 144. A lot of people will say 12. But here's the thing. Okay. I'm just about to say that, Hunter. Okay, thank you, Hunter. Because when you're coming out of the square root of 144, now, when you're solving, your highest exponent is a square. Your highest exponent will tell you how many answers you're supposed to get. So you're supposed to get 2 answers. When you're coming out of a square root, you have either a positive or a negative of a square root, right? So your answer could be a positive 12 or a negative 12. But just like Hunter mentioned, we can't have a negative length, okay? We can't have a negative height. That doesn't make any sense. So like if you're trying to build a roof on a building, oh yeah, just make that negative 12 feet. Like, no. Are you trying to go into the gullies of hell? No, you're trying to build up. So you're not going to focus on the negative. You're going to focus on the positive. Okay, so sometimes when you're just doing straight, as I like to call it, naked math, you're going to have two solutions. But if you're dealing with real world situations, you're probably just going to focus on the positive. Okay? Okay, right. You can't get a negative height. All right? Okay. All right. How are we feeling? Okay. Thank you so much for the love, guys. I know it's a little tough. It's a Friday. You just want to do something else. But I appreciate you staying in and just chiming in and saying what you got to say. Hello, Kat. All right. Thank you for the love, guys. All right. So let me see if I can. I wanted to put like a word problem. I think I can. I'm going to try to fit in a word problem. And if you're asking, well, when do we do the Pythagorean theorem, Audrey, like in real life? The one that always pops up is always TV screens, like the diagonals. Like, how do you measure how big of a TV will fit in a certain space? So I like to use the Pythagorean theorem so I could figure out the diagonal. So like when you have a TV, I'm just going to put like a quick sketch here. I want to figure out this. This is how you figure out how many inches is your TV screen. So like if you're looking at the diagonal, so you might want to do some measurement of the base, you want to do some measurement of the height and the space, and then you want to do Pythagorean theorem to figure out the diagonal so you know how big of a TV can fit in the space. Okay? Same thing if you're getting a refrigerator delivered to your house. Guys, please measure. Just because it looks amazing in the story, you're like, oh my God, I can see into it. All I have to just do is say, cuddle baby, and the door's open, and all of a sudden, like, it'll cool my beer so easily. Yeah. But can it fit through the door? All right? There's a lot of people, delivery people will come in and they'll say, I can't deliver your refrigerator. And all of a sudden, you got a refrigerator on your back porch. No. Okay? So you're always going to have to do some kind of measurements. Yes. Hey, Lynette. All right. What does the red mean? Oh, McDonald's French fries on Fridays. What? Okay. So, the red, because normally when you break down, let me slide her over. Normally when you break down a perfect square, you have a positive number, it's like a positive 12, and then you also have the negative 12, because think about it, 12 times 12 gives me 144, and negative 12 times negative 12 also gives me 144. So I was just showing that you do have two solutions, but in this case we're trying to find the height. So that's why the positive is going to make more sense, because we can't have a negative height. Okay, not a problem. All right. Okay, so let me unzoom. So you can read this. Was it or? I know. My handwriting is all kinds of off. I'm so sorry. I'm like getting a little sloppy. Found new pens. I felt nostalgic. I was like, oh my God, I haven't seen a pen like this in forever. It's probably been out forever. It just didn't. I was in the supermarket and I saw it. I was like, oh my God, I remember when I was in I was in junior high and I had a pen like this. But it was a solid mass right here at the top. You know, it didn't have, oh wait, let me do the film thing. So it used to be a solid point right here, because I remember I stabbed that one kid named Damien. He was teasing me, He was a bully. So I stabbed him once. Okay. All right. Didn't go to jail. Now I outed myself. So anyway, I know, love these pens, right? And then, oh, for all you Paisley lovers out there, Paisley colors. Who knew? All right. So anyway, it's just the little things in life. All right. So find the perimeter of a square with a diagonal 10 centimeters, and we need to round to the nearest tenth. All right, so that means we're going to need some calculator. Okay, we're going to need that calculator. But let's kind of draw it out a little bit. I might even use my purple for the Paisley pen. All right, I'm a visual learner. So if we're looking at a square, so we got, let's say 1, 2, 3, 4. I'll make it 5. Why not? Oh, all right, you're going to make a liar out of me? We're not going to do the purple? There we go. All right. So we got that 5. We have this 5. So we can get our nice, lovely square. That's the one thing I do actually like. If not with the grid, it's also with the dots. So we have 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, but they're telling us that our diagonal okay. Ooh, look at the colors. All right, so they're saying our diagonal is 10 centimeters. Okay, not as smooth as the Sharpies, but here we are. All right, so they want us to find the perimeter of the square. So that means all 4 sides of the square is congruent. Okay, all of them same measures. So we have, and what else do we know about a square that I should put into my diagram? I was about to jump ahead. Okay. All right. So what else is missing in my diagram? What's missing? What's missing? What else do we know about squares? What's missing? So we know all the sides are the same. What else? What else is the same? Yes! Good job, Marlene. Yes, the angle, the right angle. Okay, we got the equal sides, but we're also all four 90-degree angles. Okay? Don't forget about the angles. So we basically have a right triangle. So if we took a look, we have our hypotenuse. Okay, so we have our hypotenuse, which is 10, and then we just have to figure out our unknown sides. So let's say this will be my A and this will be my B, right? Okay, A squared, B squared, but since they're both congruent, I really should make them into x's. I think I'll do that instead. I'm going to make them into x's because they're supposed to both measure the same amount, right? So if we go to our formula, a squared plus b squared equals c squared. My a and my b are going to be the exact same measures. So that means we have x squared plus x squared equals my c, which is 10 squared. So let's zoom in to the calculations. Okay. So now, x squared plus x squared, what will this give me? So x squared plus x squared. What would that give me? All right, good, Bree. Hey, Guy. Okay, Scooby, good. Not to the fourth, Magic. Because since we're adding, all we're doing is combining the coefficients. This one has a 1, and this one has a 1. So that will give us 2x squared. Because when we're adding and subtracting, we're not doing anything with the exponents except to use for matching. And what's 10 squared? Okay, so Scooby-Dooby-Doo. How are you? Yes, Scooby, Diana, good. Bree, Michael, Jose, love it. All right. Now, our main objective is to solve for x. What do I need to do next? And this is the part that gets a lot of people. What should I do next? I have 2x squared equals 100. Okay, we're not square rooting yet. There's something that's in the way. Okay, good Scooby, good Bree. Ah, Deja's here, yay. Okay, good Magic and Meows, good. Michael, M, all that. Okay, right now we want to isolate that x squared. So since it's 2 times x squared, we're going to do the inverse of multiplication, which is division. So now we have x squared is equal to 50, or 50 as pronounced. All right. Okay. So now, Marlene, this is when you do the square root. Okay? Yes. But guess what? 50 isn't a perfect square. But we're not worrying about perfect squares. Because once we do the square root of both sides, the square and the square root cancels out. So we have our x is equal to the square root of 50. Now, before you start jumping in and looking at that factor sheet, go back to the questions. Okay, we need to find the perimeter. Hold on. Gotta do the puzzle piece thing. I don't know why. It's like I haven't been on here that long. All right. Zoop. Okay. All right. We got to go back to the question. And the last part, anytime they give you a question, just go straight to the end. It says round to the nearest tenth. So we don't have to look for the exact value. We are looking for the rounded value. So this is calculator time. All right. So if they gave it to you on the test, this is probably on the calculator section. So once we get, whoops, swing it on here. So we got our square root of 50. Okay. So square root of 50, if I hit enter, I'm going to get 7.071067812. They don't want all of this. Okay. They don't want all of that. They want us to round to the nearest tenth. So right now, what is currently in the 10th spot? What's currently in the 10th spot of this calculations? What digit? Just put the digit. Okay, so Scooby's saying 0. Do we agree with Scooby? Lisa's saying 7. Magic 0. Abe 7. 0. Okay, Michael's giving us the thing. 0. 0. 7. 7. 0. 0. Okay. So the 10th spot with the TH is this first decimal place. We do not have an on once. Okay, there's no such thing as once. All right, there's a 1 spot, but there's not a once. Okay, so it starts with the tenths. This is going to be the hundredths. So if we're looking at the tenths, here I go with my paper, I'm covering up the rest. And I'm just going to focus on these 2 decimal places. So I need to look here at the hundredths to figure out what to do with the tenths. So if it's 5 and above, we're going to add 1 to the 0, which it is. If it's 5 and above, we give it a shove. That means we add 1 to the next previous digit. If it's 4 and below, so 4, 3, 2, 1, or 0, that means we just end this and then just write what we see. But in this case, we're going to add 1 to the 0. So we have the ones that put their answer of, we got our X. I'm putting my approximations, and it is 7.1. All right. He's learning a lot. Keeping good work. Oh, not a problem, Greg. Oh, that's good. All right. All right. So how are we feeling with this? 5 rad 2. All right. Okay. All right. Now, if we can, not a problem. Not a problem. Feeling confident? I love that. I love that phrase. New learning. Okay. Good. All right. Michelangelo. Gotcha. All right. So I have time for one more. And I want to see if you guys can do it. All right. So let me tape it in. I know. It is what it is. Let me unzoom just a hair, and then I'm going to zoom in. Okay, so. Oops. Can't even tape straight. That's crazy. Here we go. Okay. So while I'm doing this, if you don't mind tapping it up, let's see if we can get to like 6K. That's only a couple little taps. If you want to go beyond 6, that would be fabulous. See, I'm not greedy. I take whatever I can get. All right. Okay, so now, we didn't answer last question. Yeah, we did. Oh, we didn't. We found what X is, right? Ooh, thank you, Michael. Yeah, because we only found what one side was, right? We were looking for that perimeter. So how will we find the perimeter now that we found X? Thank you, because I was just so zooming out. How would we find that perimeter? Now we got it to that hundredths spot. Okay, Hunter, good. We're going to multiply it by 4. So for us to find that perimeter, I'm just going to stick it over here. So P is going to be the value of our one side. Multiply that by 4. Because since it's a square, all the sides are going to be exactly the same. What do we get for an answer? There you go. Nice, Magic. Good. One day at a time. Thank you. Good. Michael, good. Thank you, Michael. Appreciate it. Any help I can get for possibly the next week would be fabulous. Okay, so this will be our official answer. Oh, and they did give us the units, didn't they? Centimeters. Yep. All right. Yeah, it is centimeters. Just found it. All right. Okay. All right. Now we're done with that one. Now we need this one. And we need to get this one done in 7 minutes. Because I have an appointment. Okay. All right. Work this one out. Tell me what y is. And let's see if you can round. Let's see if you can round to the nearest hundreds. If it has to be. Okay. Round to the nearest hundreds. Yes, Peggy. That's awesome. Congrats. 99.5. That's hard work right there, girl. Good job. Yes, Jonah. Right now, Pythagorean Theorem, just the beginnings. We're going to get into SOHCAHTOA next time. All right. Go ahead and put your answers in. Okay, Michael. Thanks for coming in. I appreciate you. Thanks for keeping my mind straight. You know how that's going to go. All right, so I'm seeing a series, a couple 40.13, 40.2s, a few Willie G. Hey, Willie. 40.8, Marlene 40.8, Peggy 40.8. Oh, thank you. Lisa 40.80, Tiffany 40.8, film artist 40.8. All right, I'm seeing a lot of 40.8s. Let's take a look. Okay, let me unzoom just a hair. So we have our, doesn't matter, we can just say our A is going to be like 24 squared. And we'll say our B is 33 squared. and it's going to equal our unknown, which we're saying is y squared. So when we get our 24 squared plus our 33 squared, after we do everything, it gives us 1,665. That's going to be what our y squared equals. So all I did was take the squares of both and add them together to get my 1665. So now I want to take the square root of both sides. So when I take the square root of both sides, I received, it was like 40.804 and some numbers, right? So that's what y equaled. But we want to round this to the nearest hundredth. So that means I need to look here at the thousandths. All right. So at the thousandths, it's a 4. So guess what? I don't have to worry about it because the 4 and below, we leave it alone. So we just drop everything from that thousandths or 10,000th spot, and we just keep everything else in the thousand spot. So that means we got our 40.80. And it's going to equal our unknown value of y. And since our units was inches, it's going to be 40.80 or 800ths inches. Okay. Yay! You guys are getting so good, especially the ones that are keep repeating. You guys are getting so much quicker and just so much. I know there's shortcuts, Hunter. Trust me, I do. The only thing is, like, I'm dealing with people that are just like, I need for you to go through it step by step. And that's what I'll do. It works for them. But if anything, if anybody wants to shortcut, you can do the shortcut later on. Okay? All right. Okay, ladies and gentlemen. So, if anything, if you like the pages, not a problem. Trust me. Okay, if you like the pages, oops, sorry, because I know a lot of you guys like to take screenshots. And got you over here. I think I got everything in. All right, so if you guys want to take a screenshot, go ahead and take a screenshot so you'll have it. You'll have it with your notes. If you like these pages, okay, if you love these pages, you're like, oh man, I love how it's situated. If you actually liked the factor sheet, okay, so the factor sheet that was going on back here, and you enjoy it, and you're like, oh my gosh, because multiplication is really not my thing, okay? This is my math notebook. So I have 3 versions of it, okay? One of them is the one that we know and love, the one with the psychedelic stuff. There's a green one, and then there's also one with hexagons on there. You get like 100 pages with the Cornell Notes Inspiring, so you can actually have your formulas ready to go. You don't have to go searching for them within your notes, okay? If there's anything with steps, you can write the steps on there. And then, of course, there's a lot of the sample things that's usually in the back. And I think we did, here we go. Here's our Pythagorean theorem. That was one of them. This is the next thing that's coming next week, okay? When we're talking about the SOHCAHTOA. SOHCAHTOA? Yeah, don't put your toe in some water, but that's what it is. SOHCAHTOA, your sine, your cosine, and tangent. Just so we can get a little bit of information on a couple of the rulings. All right, if you would like this book, it's on sale on Amazon. All right, you can go to the link in my bio to go to my website, and then there's something that says Ultimate Math Notebook. Click on that, and it'll take you directly to it. So it's just something that you can have if you know anybody else that needs it. Extra practice problems, you can tape it in, and then the steps on how to do things, you can do that on the other side. Okay, that symbol next to sine, cosine, and tangent. What? Theta? we're talking about right here. Yeah. Theta, the measure of the angle that we're using and referencing. Yep. Theta. No problem. Okay. All right. So if you're interested in that, just let me know, or you can go there. If you're interested in getting into a study group, like if you're currently in the class and you need some assistance and you just like, Audrey, I don't think I can afford one-to-one, but if I can come to you, I got a couple people that asked me, and some of them were saying, one person was saying 9 a.m., another person saying 9 p.m., another person was saying like 12. Okay. But be on the lookout. I'm probably going to make an announcement this weekend, as well as I'm downloading all of my lives. I'm going to try to put that on my YouTube channel. And good Lord, I didn't know I had so many lives. So anyway, and especially the ones that are over 3 hours long. Yeah, that was cray. Okay, but by this weekend, the replays should be up by Sunday, if not Sunday night. And I might pop in here tomorrow evening on a live. I'm not sure yet. I know, because I'm addicted. I'm like a drug. I'm shaking. But that's what's going on. That's what's happening. All right. Thank you guys for coming in. I know it's a Friday. Okay. Go ahead. Go to Impact. She should be live right now. And then make sure you follow the people that I mentioned. Lynette is in here if you want to talk to Lynette. And then if you're thinking about being an RN, make sure you reach out to the better RN. Okay. Have an awesome weekend. I'll talk to you guys soon. Toodaloo.